In this section, we will look at how the Linux operating system manages users and groups. As a multi-user operating system, users log in to gain an identity. Features of that identity can be viewed with the ID command. ID by itself will show information about the currently logged in user, in this case the user student. In the first field we see a UID equals 1000. This is the user ID number that goes with this particular login name of student. Every user is also a member of at least one group, their primary group. This is represented in the ID command's output with the GID equals field. Here again, this is GID 1000 with a name of student. Red Hat Enterprise Linux tries to use user private groups. When we create a new user, we create a group of the same name, placing that user into that group as their primary group. When possible, we make the GID number match the UID number. A user must be a member of one group, their primary group, but may also be a member of multiple supplementary groups. All groups are listed by ID with the groups equals field. In this case, student is not currently a member of any supplementary groups. Usernames and group names are used to identify ownership for files and processes. Those associations are then used to determine what permissions for interaction is allowed. For example, the ls-l command on a directory, here in this case /home, shows the home directories of several users that are defined on this system. The beginning of each line represents the permissions, which will be discussed in a later unit. But in the middle are two names. The first name is the owner of this particular file or directory. The second name is the group that's associated with this file or directory. Here we see that each home directory is owned by their respective user names and the primary group of those particular users. In order to verify this is a primary group, I can use ID and specify a particular username, such as test user, and see the UID number for test user, as well as the primary group is also the name test user and has a GID that matches the UID. To view the ownership of a process, we use the PS command. By itself, it shows the processes of the current environment. If I add a -u option, I see the first column now becomes the user that's associated with that process. If I add an A, I get all processes that are associated with a terminal. In this case, a couple of additional processes owned by the user root. Finally, if I add an X option, I see all the processes on the system, including background processes or daemon processes. Many of these processes are owned by other accounts on the system, such as GDM or Postfix. These are system accounts that have been created in order for processes and or files to have an ownership and then ultimately permissions to interact with other resources on the systems. Both LS and PS have shown us the user names and in some cases the group name. But the system behind the scenes is controlling access in all cases through the UID and GID numbers. Therefore, there must be a mapping between these names and the numbers. The etc password file holds the mapping for the username to their user ID number. It also holds additional account information for each of these users. The first field, looking at the test user line at the bottom of my example, the first field is the login name, the name that shows up in ls-l and ps-u output. The fields are separated by a colon. The second field, in this case an X, is actually just a placeholder. Long ago, the password used to be stored here. It is now stored in a separate etc shadow file. There are two numbers. The first of those numbers is the UID that goes with this login name. The second number is the number of the primary group for this particular user. I have a blank field here that's commonly used for a full name or other descriptive information about the account. Then I have the home directory for the user, and finally at the end, in this case /bin/bash, I have the process to run at login. This is usually the process that provides the prompt for an interactive login. The group mappings are held in the etc group file. The first field is the group name, the name that is displayed in the ls-l output. Again, there's a placeholder since there are certain cases where passwords can be applied to groups. And then there is the GID number that goes with this group name. The final field, empty in all of these examples, would hold usernames for accounts which have this group as their supplementary group. So users have an identity. They have a UID number and a login name, which are mapped through the etc password file. They have a primary group. The number is specified also in the etc password file, and the translation from that GID number to a group name, which is displayed by many applications on the system, is stored in the etc group file.